When you're dealing with exponents, you have a number raised to a power. X in this diagram represents what's called the base. That number is raised to a certain exponent represented in this diagram by the letter y. Now, when you're multiplying things with exponents, and this comes into play with scientific notation, if you were multiplying a number in scientific notation times another number in scientific notation, you need to know what to do with their exponents. And we're going to work a few examples that demonstrates this. Now, before I show you a problem with scientific notation, let me show you something that's a little easier to see. If I have 2 to the second times 2 to the third, 2 to the second is 2 times 2. 2 to the third is 2 times 2 times 2. Then I end up with 5 2's. 1, 2, 3, 4, 5. So then, what I will have done is 2 to the 5th. I could skip this step and end up with 2 to the 2 plus 3 and get 2 to the 5th. Then I don't have to write out all of those 2's. What I've just done is what's called the first law of exponents. It's written in your book on page 347, and let's go on and apply it with scientific notation. Let's say I'm working with 4 times 10 to the 4th times 7 times 10 to the 7th. What I can do is you'll multiply 4 and 7 just like normal and get 28. Then your answer is going to be times 10 to the something. The way you figure out what the something is to add 7 and 4. So then your answer becomes 28 times 10 to the 11th. Applying the concept one more time with variables, if I have y times y squared times y cubed, my answer will be y raised to the sum of the 3 powers. In this case, when there's not an exponent, we know that that's 1. So 1 plus 2 is 3, plus 3 is 6, and my answer is y to the 6th.